Good day, everyone. So our topic for today is statistics and probability. And I know that you've encountered this subject in your senior high school years. So we have learning objectives. So we have two learning objectives. So the first one is differentiate and give examples of discrete and continuous random variable, and to be able to understand probability and to compute the mean, variance, and standard deviation.
Discrete and continuous random variable. What is the difference between the two? Continuous random variable. A continuous random variable can take any value within a range or interval and it's measurable.
For example are the height, weight, and time. However, discrete random variable can only take specific countable values. For example are the number of students and dice rolls.
This is the example of continuous random variable. Shortest amount of the time to finish a triathlon. Wind speed of a super typhoon.
Speed of a race car during a race.
The height of all the female members in the house. The temperature in an air-conditioned room.
On the other side, these are the examples of discrete random variable. Number of people attending a Sunday Mass, average number of students per classroom, the amount of coins to insert in a piso Wi-Fi machine, average number of candy in a small sachet, and rating of a product from the customer.
Now, let's talk about probability distribution. A probability distribution is a mathematical function that describes the likelihood of different outcomes for a random variable.
There are two properties of probability distribution, which is number 1, p of x should be greater or equal to 0 but less than or equal to 1. And the second is the summation of p of x should be equal to 1.
Let's start with the first example. P of x is greater than 5. So let's add all the numbers that are greater than 5. P of x is greater than 5 is equals to P of 6 plus P of 7 plus P of 8 plus P of 9 and plus P of 10. Then let's distribute all the probability of each number. So the probability of 6 is 0.08 plus the probability of 7, 0.07 plus the probability of 8, 0.06 plus the probability of 9, 0.04 and the probability of 10, 0.03. Then let's add all the probability. So 0.08 plus 0.07 plus 0.06 plus 0.04 plus 0.03 is equals to 0.28. So the P of x is greater than 5 is equal to 0.28. So let's proceed to second example. P of x is greater than or equal to 1 but less than or equal to 4. So let's add all the numbers that are greater than or equal to 1 but less than or equal to 4. So P of x is greater than or equal to 1 but less than or equal to 4 is equals to P of 1 plus P of 2 plus P of 3 and plus P of 4. Then let's distribute the probability of each number. So the probability of 1 is 0.14 plus the probability of 2 0.16 plus the probability of 3 0.14 and plus the probability of 4 0.12. Then let's add all the probability. So 0.14 plus 0.16 plus 0.14 plus 0.12 is equal to 0.5. So the probability of x is greater than or equal to 1 but less than or equal to 4 is 0.56.
For the third example, p of x is greater than or equal to 3. Since the question stated that we need to find the probability of 3 or more kilos, thus, we should only include 3 kilos and above. The equation should look like this. P of x is greater than or equal to 3 equals to P of 3 plus P of 4 plus P of 5 plus P of 6 plus P of 7 plus P of 8 plus P of 9 plus P of 10. Now, let's distribute the probability of each number from the table, then we will add all of them. So, the answer should be 0.64. Thus, P of x is greater than or equal to 3 is equal to 0.64. For the last example, P of x is greater than or equal to 2 but not less than or equal to 6. Since the question stated that the probability of the demand will be at least 2 but not more than 6 kilos, therefore we should include numbers 3 to 6 only. The equation should look like this. P of x is greater than or equal to 2 but not less than or equal to 6 equals to P of 2 plus P of 3 plus P of 4 plus P of 5 plus P of 6. Let's distribute the probability of each number from the table, then we will add all of them. So, the answer should be 0.52.
So the P of x greater or equal to 2 but less than or equal to 6 is equal to 0.52. So our next topic is mean, variance, and standard deviation. Mean is also known as the average. It can be solved by adding up the values of the observations and dividing by the number of observations. This formula is called mu, and the formula of mean is mu is equal to summation of x times P of x. So later we will further know how to solve the mean of the probability. For now, let's move on to our next topic, which is standard deviation. Standard deviation is a measure of amount of variation of the values of a variable about its mean. So it's just very simple to solve the standard deviation. You will just simply get the square root of the variance. So the sign right here is called sigma. So the formula for standard deviation is sigma is equal to the square root of a variance. Earlier, we mentioned about variance. So variance is a statistical measurement of the spread between numbers in a data set. In order to solve it, we have to take the difference from the mean, square it, and then get the average result. Its formula is sigma squared equals the summation of x minus mu squared times P of x. So don't worry if you don't understand this symbol for now, because later you will deeply understand what each symbol mean and how to solve it, how it will be involved in solving the probability. So in order to know deeper, we have a situation here or a task. We have to construct a probability distribution and compute the mean, variance, and standard deviation. So we have provided a table here named Daily Expenses of Grade 11 Gas Biology students with 37 respondents. So as you can see, we have 6 rows, and the 2 rows are already provided with the information or data. So we have the amount of the student's expenses, which is represented by x, and the P of x. So in our amount of the student's expenses, we have the numbers 10, 20, 30, 50, 60, and 100. Each of those numbers have a corresponding numbers on the P of x or the probability. So in order to get the mean, we have to solve first the table or the row that stated x times P of x. So in order to get that, we just have to multiply what's in the x row to the P of x row. For example, is 10 times 0.08. From that equation, we can get 0.8. So we can use our calculator while solving these equations. So next, we will have 20 times 0.14, which is the answer is 2.8. 30 times 0.24, which is 7.2. 50 times 0.19, which is 9.5. 60 times 0.27, which is